Okay, so to find the integral of the absolute value of sine of x, remember we need to break this up. Find where the where's sine of x positive and where is it negative, because we have to split up the integral there. So the first thing you do is you need to find all the zeros from on your interval. So from negative pi over 3 to pi over 4, sine is equal to 0 at x equals to 0. So what that means is that I'm going to split up this integral into from negative pi over 3 to 0, and then from 0 to pi over 4. Then remember what you do is, and these are both going to be of sine of x. Okay, but whichever one of these intervals sine is negative, that one you're going to multiply by a negative. So since sine is negative from negative pi over 3 to 0, you're going to add a negative on the outside of that to make it positive, and then this one's going to be positive because it already is positive. Okay, so after we do that, then we can just find the integral like usual. So the antiderivative of sine is negative cosine, and so times that negative is just going to be positive cosine of x, evaluated from negative pi over 3 to 0, and then minus cosine of x, because the antiderivative is negative cosine, and then from 0 to pi over 4. Okay, so then we plug it in. Cosine of 0, that equals to 1, minus cosine of negative pi over 3, that's 1/2, so that's this first one, minus cosine of pi over 4 is root 2 over 2, minus cosine of 0 is 1. So this is 1, and then plus 1 is 2, and then minus 1. So this is going to be 3 minus root 2 all over 2. And that's it. Okay, so this one at first glance looks incredibly confusing. I mean, how could you possibly find the antiderivative of a product with what we know so far? But there's a little workaround here. You can rewrite this as, instead of e to the x times 5 to the x, you can rewrite this as 5e all to the x. I mean, this is exactly the same thing, right? And so then, but then you still have the problem that there's this 5 in here. So if this was just e to the x, that would be fine. But 5, So then you go back to your trusty, guess and check method, where you go, well, what if I just leave it alone? What if I just say that 5e to the x is the antiderivative? Well, notice that when you get the derivative of 5e all to the x, when you get the derivative, you would get 5e to the x. And then notice that, so here, you have to think of this as any other number. So this is just a number. So when you have an exponential function and you're getting the derivative, remember the derivative is itself multiplied by natural log of that base, which is 5e. That's interesting. So it's not correct, but notice that this right here, this factor, that's just a constant, natural log of 5e. So then you go, what about if you say your antiderivative is 5e to the x divided by natural log of 5e? This would work perfectly, because I would get rid of this extra factor right here. So go ahead and test that one out. I'll let you do it for fun. And you'll see that it's exactly correct. Find the derivative of this and you'll see that it's exactly this function. Okay, so then I'm going to write this slightly differently. I'm going to have 1 over natural log of 5e. I'm going to just leave that outside. And then I'm going to plug in the top, so 5e squared minus 5e to the 0. And so then this is just equal to 25e squared minus 1. So I just squared this and then minus 1 over natural log of 5e. And that's it. Okay, so we've seen a problem similar to this before. It looks incredibly challenging, but there's a workaround here. We don't have the quotient rule. So notice, we don't have many techniques for finding integrals yet. And so there's usually going to be a workaround to finding the antiderivative. In this case, the workaround, remember, is to split this up into 3 little fractions. And then once you do that, then you can simplify them. So here, for example, this one, the first one, square root of x over square root of x is just 1 minus 2x over root x. That's 2x to the 1/2. I'm going to leave them as exponents. And then this one is going to be plus x to the negative 1/2 because I'm just going to bring this one upstairs. Okay. So then find the antiderivative, right? So the antiderivative of 1 is x, and then minus antiderivative of x to the 1/2 is x to the 3/2, and then times 2/3, but there's that 2 there already, so I'm going to do 4/3. And then plus x to the negative 1/2 plus 2 is 1/2, and then times 2. Okay, so I'm going from 0 to 1. So this is equal to 1 minus 4/3 plus 2. I just plugged in 1 into all these. And then minus 0, because all these are just x's, so that's good. And so then just put everything into thirds. So this is 3/3 minus 4/3 is negative 1/3 plus 6/3 is 5/3. Okay, so to find this integral, we have to figure out where this function x squared minus 1 is positive and negative. So let's find the zeros first. Now this one is easy to find the zeros. This is at plus and minus 1. You bring the 1 over, get the square root of both sides. And then since it's a quadratic, let's do a little number line because we're not quite sure where it's positive and where it's negative. So if you plug in 0, negative 2, and 2. So what we're doing is we're basically doing the same thing that you would do if you were solving the quadratic inequality. X squared minus 1 is greater than 0. We're not really, but we're just trying to figure out where it's positive and negative. But remember, when it's a quadratic, this is what you do. You find the zeros, and then you do your number line, and you plug them in. So if I plug in 0 into x squared minus 1, I would get a negative number. And if you plug in 2, you would get positive. And if you plug in negative 2, you would get positive. So basically what this says is that it's positive for values less than negative 1 and greater than 1. And then it's negative in between negative 1 and 1. So if you're going to break up the interval from 0 to 3, then let me show you right here. So it goes from 0 to 3. And so it's basically going to be from 0 to 1. That one's going to be, so you have x squared minus 1 dx. This one, since from 0 to 1 it's negative, we're going to multiply that one by a negative. And then from 1 to 3 it's positive, so I'm just going to do from 1 to 3 of positive x squared minus 1 dx. And that's our setup. So it's really important that you get your setup correctly from the beginning. Okay, so then we just do the fundamental theorem of calculus. So I have minus x cubed over 3, and then this is going to be plus x because of this negative here, evaluated from 0 to 1. And then plus fundamental theorem again, x cubed over 3 minus x this time, evaluated from 1 to 3. And so then if I plug in 1, I would get negative 1/3 plus 1, and then minus 0. So that's this first one right here. And plus, if I plug in 3 cubed is 27, sorry, over 3 is 9, minus 3. And then, so that's just this first, that's plugging in 3. Okay, now here you have to be really careful with your signs. And then minus, plug in 1. So minus 1/3 minus 1. Okay, so that, got to be really careful right there. Okay, so we've got 1 minus 1/3, that's going to be 2/3. And then we have 9 minus 3, that's going to be 6. 1/3 minus 1. So 1/3 minus 1, that's negative 2/3 times that negative, so this is going to be plus 2/3. Okay, so 2/3 plus 2/3 is 4/3, and then plus 6, if I turn that into thirds, that's going to be 18/3. So this is 22 over 3. Ta-da! We're done.